Well, I would like to call on 4 people to help us with this. So please make sure you know how to do them. Hmm. Interesting. Two of the 4 that I will be calling were not here. So let's see. Can we start, or do you need a little bit more time for this? I'll take that as we can start. Katie, can you help us out with number 1, please?
Yeah, so I would do 140 times pi over 180.
And why are you using pi over 180?
Um,
Because it's 180 degrees, so we want to cancel those units. Are we good with that? And of course, when we talk about pi, that's pi, not degrees, but
radians.
radians. Nice. And what did you get for here?
I got 7 pi over 9.
7 pi over 9. Thank you for not like rounding to the nearest tenth or anything crazy like that. If it's in terms of like if you have a pi involved, just leave it in terms of pi. And thank you for simplifying the rest of that fraction. Are we good? Are we good? All right. Yeah, at least a nonverbal nod is appreciated when I'm checking in like that. Oh, Chloe, can you help us with number 2?
75 degrees times pi over 180.
Okay.
Pi is pi over.
5 pi over 12 is your answer? Are we good? Muchas gracias. Jojo, number 3, what should I do?
Multiply by 180 over pi.
Okay. And why is 180 on top now?
Because you're converting from the radian to degrees.
Nice. Are we good? What's that?
So the answer is 72 degrees.
72 degrees. Okay. That's comfortable. Room temperature. Hey, number 4, Joanna.
So I also multiplied by 180 over pi, and I got 126.
126 degrees. Do we agree? That's very uncomfortable. I think that might, oh, this is all frozen. I'm sorry. Here you go. There's your the answers. 26 degrees, where if you talk about temperature, is very, very hot. Speaking of which, I heard an article that India, they had one of the hottest spells over the summer. Did you hear about this? Where it was like 126, or it never got under 120 for a couple weeks. For a couple weeks. And most people don't have AC. Can you imagine? Woo. Gotta enjoy those little things. Being able to sit in a comfortable room, even when it's hot outside, even when it's cold outside. Okay, so today we are continuing the fun with our trigonometry unit. By the way, would you discuss with the neighbor where does the word trigonometry come from?
Yeah.
We didn't talk about this last time.
Yeah. Like,
Hmm. Does anyone know? Does the word trigonometry come from? No? Well, metry, what does that mean? Measurement. Like geometry is, what does geometry mean? Do you know? Measuring the world, right? Like geography is mapping the world, geometry, measuring the world, broken down into simple shapes, like a mountain. It could be represented by a triangle. Yeah, it's ultimately to measure the world. But trigonometry, do you know? To measure what? Is it triangles? So why isn't it triangleometry? Yeah. Yeah, exactly. Trigon is another word for triangle. And you've heard gons before in geometry, didn't you? Like polygon, hexagon. So trigon is just another word for triangle. So we're measuring triangles. It's all about triangles. And I think you know right triangle trigonometry already. We talked about that special 9-letter word last time. On the count of three, I'd like to hear it. 1, 2, 3. So good. So, and for right now, that's really all you have to know. And of course, these are in groups of three. Sine is opposite of our hypotenuse, et cetera, et cetera, et cetera. Are we okay understanding which side is opposite, which side is hypotenuse? I hope. But when you say opposite, it is, of course, opposite leg, and that's with reference from whatever angle we're talking about. So we're talking about this angle up here. You see what would be the opposite from that. And adjacent, it wouldn't ever be the hypotenuse. It's the adjacent leg when we say adjacent. When I was a young boy studying trigonometry, we didn't have SOHCAHTOA. This is what my teacher taught me about Oscar. Had a heap. You don't have to remember this. I think SOHCAHTOA is better. Of apples. That's how we're supposed to remember. If you see it, right, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. It's cute. It makes me feel like I'm from the countryside. But I grew up in Hollywood, so. And just a tidbit of information. Oh, 6 trig values. Are there, what, 6? There's more than sine, cosine, and tangent? What the heck? Would you check in to see with your neighbor if they have any idea what the other 3 are?
Oh, so it's like the end of the negative block. So no,
Does anyone know what they are? Yeah. One of them is cotangent. So that's the last one I'm going to talk
again, is that like the inverse of it?
about. Not quite. Okay, you're on the right track. And I'll start with talking about one called cosecant. So, and that would be cosecant of theta by definition is equal to h over O. So I did this one first because it is the reciprocal of sine. Does that make sense? If sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. The next one is secant. Do you know this word secant? Yeah, exactly. And what? Exactly. Tangents, secants. You didn't talk about cosines unless it was right trigonometry. But a secant line, you may remember, is a line that crosses a circle in 2 points, as opposed to a tangent that just touches at 1 point. Okay, so the abbreviation for secant and the definition. Secant of theta is equal to, what do you think it's equal to? By definition. H over A. In other words, the definition of secant is it is the, not the inverse, but the reciprocal of cosine. Inverse is a pretty dangerous word because there are also inverse sine functions that we'll talk about a little bit later, or maybe next year. Tangent goes to, like you said, cotangent. And I think you already know the definition of cotangent. The abbreviation is cotangent of theta is equal to A over O. Now, people have tried to make words like cho, sha, cow. I don't recommend doing that. Just go from SOHCAHTOA and flip it. And if you want to make a new word, you can, but SOHCAHTOA is kind of a home base. And then when we talk about Secant, oh, secant is the inverse, the reciprocal of sine, cosine. Secant is the reciprocal of cosine. And it is a little bit annoying. They don't match. It seems like the reciprocal of sine should be secant. And I don't know why they did that, honestly, but I'm sure they had good reasons. Okay, so it's looking for the 6. That means I'm going to do sine theta, cosine theta, and I want you to always, anytime it's asking for 6, I want you to write it in this order if possible, just to help me organize things. Is this a difficult problem? I think we already know the hypotenuse is 5. So sine is 3 over 5. And without thinking, I'm also going to do the cosecant 5 over 3. Are we good with that? The first cosine is 4/5, and I'll just fill this in 5/4. It's like before. Tangent, 3/4 and 4/3. Have I lost anybody? Good. And let's continue. Find the value of each 6 trig functions of theta for the given triangle. I'll give you a moment to work through this. I'll be calling on 3 people. Okay, I'm gonna do one row at a time, not column, one row at a time. Kyson, what'd you get for sine and cosecant?
Sine and cosecant, I got 1/3 and 3/1.
And of course, the one you wrote as
3.
3. Are we good with this? If you leave an over 1, you're risking me removing a point for not simplifying. So just make sure that eventually, if it's over 1, just forget about that one on the bottom. If it's on the top, keep it for sure. Tyson, that wasn't a lot of work, was it? Yeah, well, it was a lot of work. Man, does your brain hurt? You need to go to the nurse? Get a Band-Aid? Okay, if you need to, just go. I don't want you to be permanently damaged. Elise, help us out with cosine and secant. Nicely said.
A squared, C squared, C squared.
So something like this. You did a little bit of work like this. And what did you get for your answer?
E squared equals 8.
Okay.
Or E equals root 8. 2.
Are we good? Okay, so this is 2 root 2, and that's how you know that the answers we're looking for are
I didn't simplify it. It would be 3 over 2 root 2. You have to multiply both the top and bottom by 2.
perfect. This answer is correct, right? The answer is correct. But you're right. In this class, if this were a quiz or a test, I would want you to rationalize the denominator. So as you said, we'll multiply top and bottom by root 2, and we get this 3 root 2 over 4? Yeah. Cool. And Charlotte, the last one.
The tangent would be 1/2 and then the cotangent would be 2/2.
And when you say over 1, then you just forget about that one, right? So just 2√2. Okay. Yeah, and this should be rationalized too. So it is a correct answer, but in perfect form, I'm looking for √2/4. Just so you know, next year that is going away, the need to rationalize that denominator. The requirement will probably be going away. It's okay to leave radicals in the denominator. Just to keep that practice going, I will be asking you to rationalize denominators. Cool. There are two very special triangles that you may remember from geometry. Sometimes I have them on the board for the date. Today is not one of those times. Can you please discuss with your neighbor what are the two special triangles? Did you get them? Jojo, I just heard you say, what are they?
60/90 and 45/45/90.
Are we good? That's exactly what I'm looking for. Oh, I'm not looking to do that though. Why, why does life hate me? Oi, would you draw a nice 30/60/90 and a 45/45/90 triangle on your paper? Maybe I have to do this over here. Yeah. I think it's because I'm a lefty. I try to do a good job here. It's 30/60/90. There should be a short side. Sorry, short leg and a long leg. Would you fill in the ratios? I'm going to call this A right here, and I'm going to call this A. So what are the lengths of the other sides of these triangles? Do you remember? Check with your neighbor.
And then that would be A squared. I remember that. I know this one.
Okay, who remembers the 45/45/90 sides? Here, was that a hand up? I'm not sure. Yeah. Yeah.
X√2, X√2, and then.
Let's say that this side is A. Then this side here,
In A2.
there you go. Okay, these are both A. We recognize that's isosceles because if two angles of the triangle are congruent, then the sides opposite those angles are congruent. Does that sound familiar? It better sound familiar. And like you said, the other side is just A√2. And if you needed to, you could get that from Pythagorean theorem. But once you have these two sides, like if this is 5 and 5, you use Pythagorean theorem to get that third one. You're wasting your time. It's 5, 5, and 5√2. 8, 8, 8√2. 3, 3, 3√2, etc. Those ratios are always the same. That's called similar triangles. And who could tell us the ratio of the other sides of the 30/60/90? If that short leg is A, and one of them is 2A, isn't it? Which side? Hypotenuse is 2A, A√3. Nice. Do you see the equilateral triangle that 30, 60, 90 could be a part of to clearly visualize why that's 2a? Like if I take it and reflect that over its y alongside, do you see how 2a makes perfect sense? Right, if I do this. Now it's 60, 60, and 60, isn't it? Where all the sides are congruent. So this is suddenly 2a, 2a, 2a. And the third side you get from Pythagorean theorem, or just knowing that all 30, 60, 90 triangles are similar, therefore their sides are proportional. So we'll use this information a lot, a whole lot. So I hope you like it. If not, I hope you learn to like it. Evaluate the exact values of the six trig functions for 45 degrees. Okay, so just for reference here, I'm going to copy my 45, 45, 90. I'll actually put that 45 degrees right there. Do I have to make the, do I have to mark the other side as 45? No, we already know. I'll put this a and a root 2. So if I want the sine of 45 degrees, and that would be opposite over hypotenuse, which is 1 over root 2, which we know we're not going to leave it like that. We rewrite that as root 2 over 2. Could you do the rest of them, please? Make sure your neighbor got it right. I'm just going to ask for all of them for this person. You have them. You checked them already. Mackenzie, what'd you get?
Um, I got, oh, sorry, we already have that. For the, cosine, I got, root 2 over 2.
Okay.
And for the tangent, I got,
Are we good so far, everybody? Cool. And the other three?
for the cosecant, I got root 2.
Okay.
For the secant, and then for the cosine,
Are we good? Nicely done. Thank you. I hope that none of you took the reciprocal of this. Hopefully you can see that going back here, it's a little bit easier to take that reciprocal when the radical is in the denominator, then bring it up when you're taking that reciprocal ratio. Also, I wanted to make sure that you all put 45 degrees there, and then when we're up here, I hope that you put thetas there. If you have just sine equals or cosine equals, I promise you I'm going to be deducting at least 1 point for that. It would be like saying the square root is equal to square root of what? It has to be of something. So there has to be some indication that there's an angle happening. Can you find all six for the for 30 and 60? Let's just do 30. Let's just do 30 degrees. Check with the neighbor once you're done or stuck. Very special student. I'm going to be calling out for this one. I want all six. Did you get them? Sam, I feel like you've done. And you've been called. Can you tell us what you got?
I got 1/2.
Just meant to we agree? Okay, right. We're from the point of view of the 30 degrees, so opposite of hypotenuse. Good. Okay.
And it's briefly over.
Root 3/3 for tangent of 30, you're saying?
And
Are we good with all these? Fantastic. I'm sorry, keep going.
2,
Okay.
2/3
Okay.
over.
Any questions? Nicely done. Thank you. Now there are some identities you need to know. Do you know what an identity is? Identity is a mathematical equation that's true for all values. The easiest one is x equals x. But in trig, there's multiple identities. The reciprocal identities, that 1/, just means reciprocal. Like the reciprocal of 2 is 1/2, isn't it? So when you see 1/, something, that just says the reciprocal. So not only is the cosecant theta defined as a reciprocal of sine, we could also say that sine is equal to the reciprocal of cosecant. Did I say cosecant here? And cosecant theta is a reciprocal of sine. Also, sine is a reciprocal cosecant there. There's kind of two involved. Secant, like we said, by definition, is reciprocal of cosine. So we also know that cosine of theta is equal to the reciprocal of secant of theta. And likewise, we know that tangent and cotangents are reciprocals of one another. We'll talk more about these another time, like tangent is equal to sine theta over cosine theta. For instance, if I have a question on a test or quiz that says this, you'd be able to tell me that that's equal to tangent of 20. That's what it would be saying. We would use that identity to kind of simplify things. And cotangent, as you know, tangent and cotangent are reciprocal functions. So I hope it makes sense that the definitions are not, these identities are reciprocals of one another. And I don't want to talk too much about these today yet. We'll talk more about them another time, but at least you could reference these if you need them in your homework. Okay. Don't memorize them yet. We'll talk about it. Promise. Given sine of theta equals 8/17 and cosine of theta equals 15/17, find the remaining trig functions. Okay, well, let's see what we could do. Sine theta, cosine theta, tan theta, cosecant theta, secant theta, and cotangent theta. Okay, so it tells us this. It tells us this. Could you already do some more of these? Yeah, finish as many as you can. Discuss with your neighbor. Okay. I'd like to know what you think about this. Do you need a chance to discuss and compare? Sure, we're able to do some of these.
I'm still working.
Let's hear what you got so far.
So for, cosecant at 7 over 8.
17 over 8, I think you mean?
Yes.
Okay.
Cosine, sorry, for secant, I got 17 over 15.
Are we good with these? Yeah, exactly what I was hoping. Perfect.
I got 8 over 15.
How did you know that?
Well, sine is opposite over hypotenuse. We think both sine is adjacent over hypotenuse.
Oh,
Opposite over adjacent, I took what was the opposite and then adjacent 8. That.
I like it. So I thank you. This is really nice. Perfect. Yeah, we're talking about a triangle here, an angle and a triangle. So if we were to draw this, here's just a triangle, and I'll call this theta. When it says the sine of theta is equal to 8 over 17, like you say, that 8 is going to be the opposite side, and the 17 is the hypotenuse. And 15 is adjacent, not only because we know that's triple, but also because it tells us cosine of that angle is 15 over 17. So it all fits together. And from here, we could see that tangent is equal. Tangent of theta, like you said, is 8 over 15, you said? And very quickly from there, we can say that cotangent 15 over 18, 15 over 8. I like how you say you're still working on it, even though you've completely finished it.
Written them down.
Okay. So it's done in your head. Nice. Any questions? Nice. Now, the fact that they gave us sine and cosine means we could use the fact that tangent of theta is equal to, right? We could use this identity. I much prefer what Kara did. Right. So we could say like 8 over 17 and 15 over 17, and then crunch those numbers just so I get the 8/15ths. But I love getting to that concept of just, it's a triangle. Let's look at the side. Thanks. There's a lot to absorb today so far. So I'm gonna say let's just take a pause until 8:40. So about 3 minutes and a bit, maybe pi minutes. I don't know how many seconds are left. You gotta have a button somewhere like I'm ready to start again, but we have about 1 more minute. Are we going to talk about it? Yes, I'll mention it here. Okay, 840. Yay! At long last. Okay, here it tells us that sine of theta is equal to 1/2, and then it's looking for cosine of theta. And it says to find the value of cosine theta using a trig identity, trigonometric identity. So which identity up here relates sine and cosine? Any of them? Yeah, the one on the right, the first Pythagorean identity. So and we'll talk about why this Pythagorean. I'm going to do this in two different ways. I really like the second one I'm going to do, but since it's telling us to do it using a trig identity, I'm going to do it that way first. So I'll say that sine squared of theta plus cosine squared of theta equals 1. And I guess this begs the question, what does sine squared theta even mean? Do you know what that means? It's the same thing as saying sine theta squared. Exact same thing. But we can't say sine theta squared because that is ambiguous, isn't it? It looks like you're squaring the angle. So you could write it like this, but just for efficiency's sake, mathematicians have agreed that the 2 is right after the sine. It means sine theta squared. But like when you're doing your work, you could just do it as we have here. So sine theta squared plus cosine of theta squared equals 1. It tells us that cosine of theta is equal to 1/2 squared plus cosine theta squared equals 1. 1/2 squared, I believe, is 1/4. I'm going to subtract that from both sides, giving us cosine squared theta equals, what is 1 minus 1/4? Oh, 3/4. And I went back to standard notation because since I'm so used to it, it was just annoying for me to put those parentheses there. You can keep them if you like. Next step, since I'm looking for cosine, is to take the square root of both sides. That's how we get that cosine of theta is equal to root 3 over 2. Are we good with that? Almost root 3 over 2, plus or minus. And we'll talk more about that plus or minus thing. But the fact is that this is in the first quadrant. So does any sort of negative, not first quadrant, it says it's acute, which means it's in the first quadrant. So negative doesn't make any sense for this problem. So I'm going to say Q1. Therefore, the answer is root 3 over 2, just a positive. The other way to do it, yeah,
Draw the triangle.
draw the triangle. Exactly. And we have our triangle here. I'm going to put my theta. It tells us the sine of theta is equal to 1 over 2. That means the opposite is 1. The hypotenuse is 2. If I want to know the cosine, how do I find this third side? Either we know that it's root 3, or if we didn't know, we'd have to use the Pythagorean theorem to get there. So it's all connected to Pythagorean. So yeah, but we do get root 3 because we know that's a special triangle. So immediately we could get that cosine of theta is equal to root 3 over 2. And that's definitely how I would do it, without a doubt. Right, that Pythagorean identity is great, but only use it if necessary. I recommend always referencing the source, the triangle, source of all happiness. I'll give you a moment to do example 7. Either using a trig identity or a triangle. We'll be calling on one happy student. Get it? Check with the neighbor once if you are done or stuck. Okay, Ella, what'd you do for this one?
Through the triangles, the hypotenuse is 5, and the bottom leg is 4.
Okay.
You know, and then I just use Pythagorean theorem to solve for each.
Okay. Do we need to use Pythagorean theorem? Yeah, it's one of the Pythagorean triples. So you can use Pythagorean theorem or just know if the other sides are 4 and 5, that's just 3. And that's how you know that the answer that we're looking for is 3/5. Are we good with that? Happy little problem. Nicely done. I have an exercise for you. Are you ready? I think you're gonna like it. It's not in the packet. It's here. I prepared especially for you today. Yeah. You're welcome. Yeah. Okay, so did everyone get one? We're gonna start with this side. How many of you have ever been to the supermarket? How many of you have looked at the pies in the supermarket? Have you ever? No. Have you ever seen the half a pie? Like if you don't have full pie, that they sell half pies, or even pies by the slice. So what we're dealing with here is 4 half pies, and it's your job to cut these into equal pieces. So what I'd like you to do is take some time to cut this into 2 slices, perfectly even. Like if one person got smaller one, they'd be unhappy. So it's got to be even. This one into 3 slices, this one into 4, and the last one into 6 slices. Does that make sense? I know it feels like we're in elementary school again. I think the ones on the right are the hardest. So make sure that you erase and do a good job. Do a good job if you've done a bad job. Once you're done, just compare with your neighbors. Maybe even hold them over each other, hold them up to the light and see how close they are, if you want. Did you get him? Does that seem about even? Sam's nodding his head. You're fired, Sam. You cannot work in the supermarket cutting pies. I'm sorry. If we want to cut into two slices, we're just going to make that cut right about here. Sam once again nods his head. And I appreciate your support, Sam. Thank you. We make the cut. We find that center there and just kind of cut straight down. Oops. Something like that. Is that what you did? I hope that's what you did. If you want happy customers, that's how we're going to cut it. Would you please show me how you cut three slices? Yeah, exactly. So you just cut it in half. And then like this. Is that what I'm saying? No, again, that's a crappy job. Okay, I just have to move this over, I think. Maybe like that. Is that pretty good? No, this is terrible. I did a bad job. That's too wide, isn't it? They're too wide. I'm gonna have to cut these into like, I don't know, maybe there. Does that seem maybe right? It's much harder than two slices, don't you think? So four slices is even harder than that, though, isn't it? No, first you cut it in half. Did you do that? Okay, first you cut it in half. Since it's even, we could do that. And then each one of those halves, you cut in half. Bam. Something like that. Are any slices the same in the four slice and the three slice? Like slightly different. Okay, and for the six, would it make sense to have the first cut like right there? Should I do that for the first cut? No, it's too difficult to figure this out. So first we'll cut it in half, and then each one will slice into three even pieces. Is that how you did this? Yeah, okay. I'm not happy with that. Okay, I'm happy with that. Okay, there we go. Now notice, oh, are we okay with this? Sorry about my warbly lines. It is the stylus issue, I promise. Especially diagonal lines. It tries to straighten them or something. So this is a worksheet not on pies, but radians and degrees. And remember, when you're talking about an angle in standard form, where does it start? It starts at x-axis in the positive direction. So I'm going to mark some degrees here. Like here's 0 degrees. I hope it makes sense at the top. I'm going to put degrees. The top, I hope it makes sense. I'm going to put 90 degrees. Does that make sense? And then all the way would be 180. But that's degrees. And remember, 180 degrees is pi radians. So I'll put the radians just below, right next to it. So 90 degrees, does it make sense that that is pi over 2? Because we cut that pi in half, so pi over 2. We're going to do the same thing for the three slices. Let's do degrees first. 0 degrees. The next one is how many degrees? Is it 60? How do we know it's 60? It's a third of 180. Exactly. Yeah. So 60 degrees, which means the next one is 120 degrees and then 180 degrees. And when I say 60 degrees, what I'm doing is I'm imagining our initial side there being on the positive X direction and then angle opening up this way to hit that first slice. And for that other one, there's a 120-degree angle. Does that make sense where these degrees are coming from? If I want to label these as radians, well, 0 degrees is the same thing as 0 radians, but 60 degrees is going to be pi over 3. Why 3? Because we cut into 3 parts. So if that's 1 pi over 3, I hope it makes sense that the next part is going to be 2 pi over 3. And then the last one really is 3 pi over 3, which is, I believe, Can you please label the degrees and radians for the remaining slices? Check in with your neighbor. Make sure they got it right. I will be calling on two people, one person for the 4 slices, one person for the 6 slices. Did you get it? Yeah, both of them? If you're not sure, again, check in. I will be calling on someone in about 12 and a half seconds, starting now. Okay. Haley K, could you tell us what you did for these starting at 0?
90, 135.
Okay. And radians?
Then 0, pi over 4, pi over 2, 3 pi over 4.
And pi. Are we good with these? Isn't it nice that pi over 2 works out, the 2 pi over 4, 3 pi over 4? It works out. Beautifully done. Thank you, Haley. And for the last one, Joanna.
So 0, 30 degrees, 60 degrees, 90 degrees, 120, and then 150. And then for 30 degrees, it'd be pi over 6, and then 2 pi over 6, 3 pi over 6, 4 pi over 6, and then 5 pi over 6.
And then the last one is 6 pi over 6. Okay. Which I'm just going to write automatically as pi. And we know that pi is equal to 180 degrees. And of course, we aren't finished with this, but this is an intermediary step because we always have to simplify the fractions. That's why you're going to make the 2 pi over 6. You're going to turn that into pi over 3. Have we seen that pi over 3 before? Yeah, it was in that one above. And also 4 pi over 6 is 2 pi over 3. Have we seen that 2 pi over 3 before? Yeah, for sure. Thank you, Joanna. Oh, look what's on the back. 2 full pies. Would you please cut this one into 8 slices? And this one into, how many slices should we do the next one? 2, 4, 6, 8, 10. There's 12 of you. Let's do 12 slices. Do a good job. Label each slice degree and radians all the way around. Something like that, I think. Eight's so much easier than the 12. Once you're done cutting it up, don't forget to label each slice with both degrees and radians. In the end, how many radians are you going to end up with? 2 pi, right? All the way around is 2 pi. Make sure to simplify any fraction along the way. We're finding this exercise pleasant. Sorry, I don't have crayons. Please check in on your neighbors, see how it's going. If they are slower than you, what's holding them up? If they're faster than you, how are they going so fast? The first one together, 8 slices. I'm gonna ask you to put your pencils down for a moment. Let's do the 8 slices together. Degrees wise, each slice is how many degrees? They're all the same, aren't they? They're all 45 degrees. And how do we know that? Half of 90, right? We don't have to say 360 divided by 8. We take that quarter and cut that in half. So 90 divided by 2 gives us 45. So as I go around in degrees, I'm just gonna take that 45 and just say plus 45. We already know that's 90, 135, 180. What's next? 225, 270, 315. Yes. And finally, 360. Yes.
Zero slash 350, I mean 360, should we just have one of the others?
I'll just be prepared to do either one because it's the same angle, the same direction. Zero is the same thing as 360. They're known as what kind of angles? Co-terminal. Okay, so radians. We're gonna start with 0 radians. Yay. The first slice is how many radians? How do we know it's pi over 4? Yeah, the top is just cut into 4 pieces. So that's our first slice. And since all the slices are the same, I'm just going to count 1 pi over 4, 2 pi over 4, 3 pi over 4. Yes? 4 pi over 4, 5 pi over 4, 6 pi over 4, which I'm going to simplify immediately. That's 6 pi over 4. And then the last one is 7 pi over 4. Oh, and one more, of course. 8 pi over 4, which is 2 pi. Does that make sense? Are you annoyed that I left it as 2 pi over 4? Me too. I'm going to change that. Pi over 2. So that's how I want you to go around. I don't want you to do much work. I just want you to be able to count, basically. Did you need a little bit more time for the 12 slices? Can you just check to make sure your neighbor got the same thing you did? Okay, I'm gonna ask someone for degrees. Someone is called Ella. I'll start for you. 0 degrees.
30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210 degrees, 240 degrees, 270 degrees, 300 degrees, 330 degrees, 360.
30 degrees. Thank you. I do need to put degrees on here because if I don't, then the implication is that we're dealing with radians, and that would just be wrong. So thank you for saying that each time. Are we good? Ella, do you want to do the radians too? I feel like that was maybe too easy.
So, for 30, it's pi over 6, then pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, 8 pi over 6, which is 4 pi over 3, 3 pi over 2, 5 pi over 3, and then 11 pi over 6, so you can then 2 pi.
And this one, what was the next to last one? 11 pi over 6. Well, and then 2 pi. So this is 0 or 2 pi. Are we good? Now, when you did it, did you automatically do pi over 3 here?
Well, for that one, I just wrote 2 pi over 6 and can simplify it pretty easily. Because it's easier to just go around and do 6 on each of them first.
Does that make sense? It's really just counting. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 7 pi. That's 6 pi over 6, 7 pi over 6, 8 pi over 6, which simplifies, etc. So this is a way to connect the degrees and radians so that you don't have to multiply by the pi over 180 or anything like that, right? So I'm helping you connect exactly these special places on the unit circle. And you've seen that, this is the unit circle, by the way. You've seen this all year, I believe. Does it make sense? Like it may have annoyed you. Why isn't it even? Do you see why it's not even? Think about it. Okay, I hope you enjoyed this. You have a few minutes to get started on the assignment, so I'll give you some time for that.